Please stop the talking. Unit 12, Lesson 2, Inscribed Angles. This is Math 2. We're going to start off defining what an inscribed angle is. An inscribed angle is an angle whose vertex is on the circle. Please stop the talking. Whose vertex is on the circle. So, I want to quickly review with you what we did on Monday to then show you how it's going to differ today. So this first one is review, and I said Monday, but I meant Friday. This is the one we did on Friday. You have your circle, and we called it a central angle is what we worked with. Does anybody remember what a central angle is, where its vertex is at? You can look back at your notes. The vertex is at the, right here kind of in the title, it's at the center. So let's call the center A, circle A. That's a circle with center at A. And I come out to the edge of the circle like so. And I call this B and this C. Is angle BAC a central angle?
Yes, ma'am.
Yes. Does that make sense? And what was the relationship between this angle measure and this arc measure? Do you guys remember? No one? They were what? Twice as big, half as big, the same, twice as big? Okay, it's in your notes from last week. It's right here. Arc measure equals what? The corresponding central angle. So what's the relationship between that arc measure and that angle? They are equal? Okay, so we would say angle, the measure of angle BAC is congruent to the measure of arc BC. This arc is congruent to that angle, or equal to. Stop the talking. Put your phones away. All right, so that part is review. The new one that we're dealing with today is called an inscribed angle. And this one has a vertex on the circle. So draw your circle. Put that away. Okay, so this time I'm going to put A on the circle and come out to B and C. And today's assignment will have a mixture. The whole front page, I believe, is this, and the back page has a mixture of the two. Okay, do you guys see the difference between these two? This one, the vertex is at the what? Center. And this one, the vertex is on the center or on the circle? On the circle. Do you think they're equal? Do you think this angle is equal to that arc? Does it look like, you can see here how it would be? Does this one look like it? If this BC was the same, does this angle A look the same, or does it look smaller or bigger than this angle A? It does look a little smaller. Here's the relationship. The measure of angle BAC is congruent to, so here's BAC, and it's not equal to BC, but it's equal to half the measure of arc BC. Do you guys see the difference between these two? When it's at the center, they're exactly equal. When it's inscribed, the angle is half the arc. Is that the same as saying the arc is twice as big? For example, could you write it like this? The measure of arc BC equals twice as much as angle BAC. Yes or no? Yes, you can go both ways. All right, let's try some examples. Number 1. Draw your circle. Okay, I'm going to put this out here is 100 degrees. This here is 120 degrees. This is angle A, and this arc out here I'm going to call arc C. And I want you to find A and C. Okay, does anybody know which one I'm able to find first? C. Do you guys see why? What do we know about completely around the circle? What does it measure? 360. If this is 360 and this is 100 and this is 120, how can I use the 120 is all of this, the 100 is all of that. How can I use those two to find C? Good job. So 100 plus 120 plus C equals what? 360. Can you guys go ahead and solve that now? You guys have your calculators out. Okay, so 220 plus C equals 360. Go ahead and subtract. What does C equal? 140 degrees. Okay, so if this is 140, how do we use that to find A? Would I double it or cut it in half? Cut it in half. Because from here inside, I cut in half. From the inside outside, I get bigger. I double. Can you guys see that? From here going in, it is getting smaller. Do you guys see that? So A would equal 140 cut in half, or half of 140. So what does A equal? What is it? 70. Questions? Number 2. Oh. All right. Draw your circle. Okay, I'm going to put this in here is 28x minus 12 degrees. What is this angle in here called? Is that a central angle or an inscribed angle? That is a central or inscribed. Gentlemen, I need the talking to stop. Inscribed. The vertex is not at the center, it's on the circle. Do you guys all see that? Okay, the measure of this arc out here is 200. I want you to find x. Okay, what is the relationship between this angle and this arc? Are they equal? Yes or no? This angle, which is inscribed, does it equal that arc? Look here, yes or no? No. Okay, what can you say about this angle in relationship to that arc? Which one do I cut in half, the 200 or the angle? Which one do I cut in half? The 200. Now, if it was, like say the equation was out here and it was too hard to cut in half, would it be easier to double the inside? And not in this problem, but in other problems, could it be easier to double the inside? Yes, do what's easiest, half of the outside or double the inside. In this case, it's pretty easy to do half of the outside, so 28x minus 12 equals what? What is it? And how did you get that? 200 divided by 2. 28x minus 12 equals 100. Go ahead and solve. Add your 12, divide your 28, and find x. And what do you get? X equals what? 4. Questions? No questions? Okay, can I move on? Alrighty, number 3. Alright, I'm going to do my best to draw this because looking at my picture, it's very messy. So draw your circle first. And I suggest you draw this with me because if you do not and you try to come back in, it's going to be confusing. Okay, that 39 degrees is going to be a lot more, but is that 39 degrees a central angle or an inscribed angle? Inscribed? Okay. I'm going to draw a center. That right there is the center. We'll call that center A. I'm drawing a diameter going through center A, connecting to that endpoint there. Did everybody see it? Okay. Again, there's going to be quite a bit more. So is everybody drawing with me so far? And we're all caught up. You have this inscribed angle. We have this diameter. I'm going to draw another inscribed going there to there, and I'm going to call that angle B. Okay, I'm going to call this right here 50. That's this little arc from that dot to that dot is 50 degrees. This one out here is 130, and I recognize my drawing is not drawn to scale. Let's pretend that it is. And I'm going to call this arc from here to here A. Lowercase a. And I'm missing one somewhere. Oh, right here. Okay. This one here. There's one more. Are you guys ready? From this dot to that dot. That one is C. So you can see where it can not only get kind of confusing to draw, but even kind of confusing to read. Okay, are we all ready? Yes? Okay. What is the measure of A or B or C? Where can we start? Anyone have any suggestions? A first. Okay, let's start with B. What can we say about B? Anyone? Okay. First off, do you guys agree that B is this angle right here? Yes or no? Okay. And it intercepts this arc here. What's the measure of this arc right here? What is it? One what? 180. So does B equal 180 or half of 180 or double? Half. Half of 180. So what does B equal? 90 degrees. All right, I want you to look at this next one. Please stop. I want you to look at C. You have enough right now to find C without any extra work. So go ahead and do that now. This is its intercepted arc here. It's okay. For the next one. All right, guys, what did you get for C? Anybody? Okay, C, give me an equation. What did you do?
130 divided.
Half of 130? Yes or no? Ladies, knock it off, please, and put that away. Okay, so what does C equal? 65? Okay, and last one we have not yet found is A. Okay. Any thoughts? A is, if I can use a different color, this piece right here. And it does have an inscribed angle. Can you guys trace these endpoints to its inscribed angle? Do you guys see it? What is its inscribed angle? It's right here. Can you guys see that? Yes or no? Endpoints of my arc, I trace in. Is that the inscribed angle? What's the measure of that inscribed angle? Does A equal 39? Half of 39, or twice as big as 39? Okay, so A equals double the 39. Do you guys agree? So you really need to keep track of when you're cutting in half and when you are doubling. When you're cutting in half and when you're doubling. I'm looking for the arc, so I double the angle. So what does A equal? What is it? 78. Any questions? Okay, take your packets out. Take your packets out. All right. First one. This whole numbers 1 through 3. Please stop, guys. It says solve for x. X is here. What's the relation between x and, I can't read that. Is that a 90? Yes. Are they equal, or do I double, cut in half? What do I do? I want to work with this number. What do I do with the 90? Cut in half. Does everyone agree with that? X equals half of 90. What does x equal? 45? Okay. Next one, look at your x. Now your x is the arc. Do I say x is equal to half of 37 or double 37? Double. Again, know when you're doubling and know when you're cutting in half. So what does x equal? 74. I'm going to let you guys continue to work. Does everyone understand the difference between when you cut in half and when you double? If they give you the arc, you cut in half to bring it into the angle. If they give you the angle, you double it to bring it out to the arc. Okay, go ahead and keep working. Actually, let's do 3 together. Okay, I double what? I double what? 50. So is this down here 100 or this piece right here? Okay, so if this is 100, is 100 my answer? No, x is over here. How can I use this 100 to find the x? Yes? What is this piece right here called? A semicircle. So 100 plus x equals what? Equals 180. Are you telling me that x equals 80? Is that what you're saying? Do you guys agree? Okay, keep working.